So, you've got this awesome idea for an electronic gadget, but you're kind of stuck on how to actually build it, right? Well, that's where custom circuit boards come in. And in this explainer, I'm going to walk you through designing your very first one completely from scratch. We'll be using KiCad. It's this super powerful, totally free tool that will help you turn your ideas into a real physical thing. Let's dive in. So here's the game plan. We're going to tackle this in 5 main stages. First, we'll get our digital workshop all set up. Then we get to the fun part, creating the blueprint of our circuit. After that, we'll turn that blueprint into an actual physical design, laying everything out on the board. And finally, we'll get it all ready for manufacturing by exporting the right files. It's a whole journey from concept to creation, and I'll be here with you for every single step. All right, first things first. Before we can do any of the cool design stuff, we have to set up our digital workbench. That means getting KiCad installed and creating a brand new project. This project is going to be the home for everything we make. Getting KiCad is super easy. Just head to their website. But let me give you your first pro tip. And seriously, trust me on this. When you create your new project, always check that little box that says create a new folder for the project. I know it seems small, but doing this one thing will save you a world of pain later. It keeps your schematic, your layout, everything all tucked away neatly in one place. Once you do that, just double-click that schematic file and we're off to the races. Welcome to the schematic editor. This, my friends, is where the magic really starts to happen. You can think of this as the brain of our whole operation. We're not just drawing lines and symbols here. We're literally creating the digital DNA for our circuit, telling every single component what its job is and how it should talk to all the other parts. Now, before we go crazy and start dropping components everywhere, let's just do a tiny bit of housekeeping. Pop into the page settings. This is where you can add your project title, maybe a version number. It's super helpful for keeping track of things down the line. And speaking of helpful, do yourself a huge favor right now and set up your autosave. I like to set it to 3 minutes because, believe me, there is nothing worse than losing an hour of hard work because the power flickered. It is absolutely soul-crushing. All right, you want to know the real secret to becoming a KiCad Pro? It's shortcuts. Seriously, learning these will be a total game changer for your workflow. Hitting A to add a component or W to start drawing a wire is just so much faster than clicking through menus. These 7 shortcuts right here, they're your new best friends. Get these into your muscle memory and you'll be flying through your schematics. Okay, listen up because this is a super important tip for anyone just starting out. When you're drawing wires with the W key, you have to make sure you see that little solid circle pop up when you connect to a pin. If you just draw the wire over the pin without clicking on that connection point, it'll look connected, but electrically, it's not. It's just floating there. This tiny mistake can cause massive headaches later, so always zoom in and make sure you've got that solid connection. And there we have it. Our schematic is complete. We've built the logical heart of our circuit. But now it's time to translate this blueprint into the real world. We need to tell KiCad what our components are actually going to look and feel like when they're sitting on a physical board. And the key to this whole process is a little thing called a footprint. Think of it like this. Your schematic might have the symbol for a resistor, but the footprint tells KiCad the actual physical size and shape of that resistor. It's the pattern of copper pads that you'll actually solder the part onto. Getting this right is absolutely crucial. So, assigning footprints is pretty straightforward. You open up the tool, you pick a component from your list, and then you just browse through KiCad's massive library to find the one that matches. And here's one of my favorite features. You can preview the footprint and even see a full 3D model of the part. This is incredible. It lets you catch potential mistakes right away, like realizing that capacitor is way bigger than you thought it was. Okay, let's get physical. All of our components now have their real-world identities, so it's time to jump over to the PCB editor. This is where we stop thinking in abstract diagrams and start playing a game of Tetris with real components on a virtual circuit board. This is where it starts to look real. The very first thing you're going to do in the PCB editor is hit that Update PCB from Schematic button. This is the moment where KiCad pulls in all your components and their footprints. You'll also see all these thin white lines crisscrossing everywhere. We call those rat's nests. And yeah, it looks like a mess, but don't panic. Those lines are actually your guide, showing you every single connection you still need to make. Just be sure to watch that output window for any errors. If you see one, you've got to go back to the schematic and fix it first. So as you're placing your components, you might open up that awesome 3D viewer and notice, wait a minute, one of your components is missing. It's invisible. You can see its copper pads on the board, but the 3D body just isn't there. Don't worry, this happens all the time, and it's actually a really easy fix. The great thing about KiCad is that you can just add these 3D models yourself. Do a quick search online for your part number plus the words step file, and you'll almost always find one. Just download it, drop it into KiCad's 3D models folder, and then link it to your component's properties. You might have to nudge it around a bit to get it perfectly lined, but then, boom, your 3D view is complete and looks super professional. All right, it's time to connect the dots. You basically got two main ways to do this. First, there's routing. You hit the X key and you literally draw the little copper highways that the electricity will flow through. Now, if you hit a roadblock on one layer, you can just press V to drop in a via, which is like a tiny elevator that takes your connection to the other side of the board so you can keep going. The other method is to add a ground fill, which is like pouring a giant sheet of copper over your entire board. This is awesome because it automatically connects all your ground points and makes your whole circuit more stable. It's a massive time saver. We are so close. We're in the home stretch. Our components are placed, all our connections are routed. The only thing left to do is add some final finishing touches and then package the whole thing up into a set of files that a factory can use to actually build our board. So silkscreen is basically just the text that gets printed onto your board. KiCad puts labels on for you, but honestly, they're usually all over the place. Taking just a few minutes to clean them up is what really separates a decent board from a professional one. Just hide the copper fill for a second, select the silkscreen layer, and then use your M and R keys to move and rotate the labels so they're neat and easy to read. This is also your chance to add your project name or your signature. And here we are, the grand finale, exporting your Gerber files. These files are the universal language that every single PCB manufacturer understands. You'll open the plot menu, make a new folder just for your Gerbers, and then tell it to plot all the necessary layers. You'll also have to generate a separate file for all the drill holes. And the very last step is to just zip up that whole folder. That one zip file, that's your golden ticket. That is what you upload to the manufacturer to get your board made. And just like that, you've done it. You went from a totally blank canvas all the way to a complete, professional, ready-to-manufacture PCB design. You now have the fundamental skills to take any electronic idea out of your head and turn it into reality. So the only question left is, what amazing thing are you going to build next?